In this lecture, we'll explore inheritance in Python, which is a key concept in object-oriented programming. We'll start by understanding what inheritance is and its importance. Next, we'll create a simple parent class and then define a child class that inherits from it. We'll go through how to override methods and add additional methods in the child class. We'll also see how the child class can use inherited attributes and methods. Then, we'll briefly touch on multiple inheritance and use the functions isinstance and issubclass to check instances and class relationships. Inheritance allows a new class, known as the child class, to inherit attributes and methods from an existing class, which is referred to as the parent class. This helps us reuse code and makes our programs more organized. In Python, the parent class is also called the base or superclass, while the child class is known as the derived or subclass. Let's get started by creating a simple parent class. We'll create a new Python file named inheritanceexample.py inside our class folder. In the file, let's define a class called animal. We'll include an init method to initialize some attributes for this class. It initializes two attributes, name and species, using the values passed to the method when an instance of the class is created. We can also add a method called makeSound that prints a message including the name. Now, let's create an instance of this class to see how it works. We do this by calling the animal class and passing values for name and species. Here, we created an instance called myAnimal and set the name to Buddy and the species to dog. When we call myAnimal makeSound, it uses the makeSound method from the animal class to print a message. This shows how the instance myAnimal has the attributes and behavior defined in the animal class. Let's run the script. We should see this output, confirming that our parent class is working as expected. Now that we have our parent class, let's create a child class that will inherit from it. But before that, I'll add a few horizontal lines using comments starting with a hash, followed by repeating dashes. This helps visually separate different parts of our code, making it easier to identify and navigate the sections as our script grows longer. Now in the same file, let's define a new class called dog that inherits from animal. Note that we used parentheses to specify the parent class that the new child class will inherit from. Next, let's add a constructor method that takes name and breed as parameters. Inside the constructor, we call the parent class's constructor. This allows us to set the name attribute via the parent class and fix the species attribute to dog. Note that the super function is used to have access to the parent class and call its init method to set up inherited attributes. After that, we'll add a new attribute called breed, which is specific to the dog class. It must be initialized using the breed input parameter. So we created a new class called dog that inherits from animal. Next, let's define an instance of the dog class. We name this instance myDog and use the dog class constructor to initialize it with the name Buddy and the breed Golden Retriever. The next line calls the makeSound method on the myDog instance. Since the dog class inherits from the animal class, it uses its makeSound method. The next line prints the name and breed attributes of the myDog instance. The name attribute is inherited from the animal class, while the breed attribute was added specifically in the dog class. This demonstrates how the dog class can use both inherited attributes from its parent class and new attributes defined within itself. Let's run the script again. As expected, The dog class inherited the makeSound method from the animal class and also utilized its own breed attribute. Sometimes we want to change the behavior of a method in the child class. This is called method overriding. Let's override the makeSound method in the dog class to provide a more specific message. We redefined the makeSound method in the dog class to print a message indicating the dog is barking. Now, let's call the makeSound method of our myDog instance. Since we have overridden this method in the dog class, it will use the new version defined in dog, rather than the one from the animal class. Let's run the script again with the updated class definition. This time, we see that the dog class uses its own version of makeSound instead of the one in its parent class. In the dog class, we already added an attribute breed. Let's now add a new method that is unique to the dog class. I'll add a method called fetch that takes an argument item and prints a message saying that the dog is fetching it. Let's try using this new method and passing ball as input. Then, if we run the script, we'll see this output. So we have now extended the functionality of the child class by adding a new method. Now that we've added attributes and methods to our dog class, let's briefly highlight the power of using inherited attributes and methods. Inheritance allows us to reuse code from the parent class, which helps keep our code organized and reduces redundancy. By inheriting the name and species attributes and makeSound method, the dog class becomes an extension of animal, allowing us to build more specialized behavior without starting from scratch. This structure provides flexibility, as we can easily add or override features in the child class while still maintaining the base functionality provided by the parent. So far, we've explored how a child class can inherit from a single parent. Now, let's dive into the concept of multiple inheritance, where a class can inherit attributes and methods from more than one parent. Here's a quick example, where we add another class called swimmer. This class has a method named swim that prints a message when called. We'll add swimmer as another parent class to dog, allowing it to inherit attributes and methods from both animal and swimmer. Now, let's use the swim method inherited from the swimmer class. We'll call this method on our myDog instance. Let's run the script again to see the output of the swim method. This output shows that the dog class successfully inherited the swim method from the swimmer class. When a class inherits from more than one parent, Python needs to decide the order in which it looks for methods or attributes. This is known as the method resolution order, or MRO. The MRO defines the path Python follows to find the method or attribute when there are conflicts, such as when different parent classes have methods with the same name. In Python, MRO follows a left-to-right depth-first order based on how the parent classes are listed. We can use the MRO function to see this order for any class. Let's check the MRO for our dog class. When we run the script, it displays the method resolution order for the dog class, showing the sequence in which Python will search for methods and attributes. With our understanding of multiple inheritance and MRO, let's explore how to check relationships between objects and classes. The isinstance function helps us determine if an object belongs to a specific class. If I run the code, here is the result of checking if my dog is an instance of the dog class. and this one shows it is also an instance of the animal class via inheritance. Similarly, issubclass checks if a class is a subclass of another. If I run again, this output confirms that dog is indeed a subclass of animal. To summarize, in this lecture, we explored how inheritance allows us to create new classes from existing ones, making our code more reusable and organized. We created a simple parent class, animal, and a child class, dog. We covered how to override methods, add new attributes in methods, and use inherited ones. We also touched on multiple inheritance, explored the MRO function to understand method resolution order, and used isinstance and issubclass functions to check object and class relationships.